Hi there everyone. Welcome to the first grade 9 algebra lesson. In this lesson, we want to have a brief look at sets. Then we also want to have a look at the following number systems: the whole numbers, the natural numbers, the integers, the rational numbers, the irrational numbers, the real numbers, and the non-real numbers. So let's have a look at what we mean by a set. A set is a collection of distinct objects. In other words, a collection of objects that we can distinguish from each other. An example of a set is as follows. A is a set of colors of the traffic lights. Then we'll write a set A with the objects red, amber, and green in curly brackets. Another example is B is a set of odd numbers between 0 and 8. So B will consist of the numbers 1, 3, 5, and 7. It's not always possible to list all the objects in a set. Let's say C is a set of even numbers greater than 7. There are many even numbers greater than 7. So we list only the first 3 numbers, in other words 8, 10 and 12, and then we use dots to show that the set continues. It's also worth mentioning that a set can consist of virtually any objects that we decide to be in it. For example, D can be the set of smiley face, heart, and flower. Let's have a look at what we mean by an element of a set. An element of a set is any one of the distinct objects that are in the set. We use the Greek symbol epsilon to denote an element with. For example, let's say A is the set 1, 3, 5, and 7. Since 3 is an object in the set, we say that 3 is an element of A. The number 4 is not in the set, so we say that 4 is not an element of A by drawing a line through the symbol epsilon. Let's have a look at what we mean by a subset. We say that the set A is a subset of the set B if all the elements in A are also in B. We use a symbol which looks a little bit like a C to denote is a subset of. For example, let's say A is a set 3 and 7, B is a set 1, 3, 5, and 7. Both 3 and 7, which is set A, are also found in set B. So we say that A is a subset of B. Let's say D is a set 3, 7, and 4, and B is a set 1, 3, 5, and 7. Not all the elements in D are also in B. The element 4 is in D, but it's not in B. So we say that D is not a subset of B by drawing a line through the symbol for the subset. Let's again look at the set A, which consists of the objects red, amber, and green. Instead of using curly brackets to denote the set with, we can also use a circle and write the objects inside the circle. Let's say B is the set consisting of the objects or numbers 1, 3, 5, and 7. We can draw a circle for the set and then write the numbers 1, 3, 5, and 7 inside the circle. This is known as a Venn diagram. We can also use a rectangle or an oval to denote a Venn diagram with. We can also use Venn diagrams to denote subsets with. Let's say A is a set 3 and 7. B is a set consisting of 1, 3, 5, and 7. We saw previously that A is a subset of B because all the elements in A are also in B. We can denote this with Venn diagrams. Since A is a subset of B, we draw A entirely inside B. and list the elements 3 and 7 in it. The elements 1 and 5 are elements only of B, so it's drawn outside the circle for A. You should pause here and try this question before looking at the answers. Let's look at your answers to this question. We were given the set A, which is a set of vowels, and we had to say whether each of the following statements is true or false. In the first one, it says I is an element of A. If we look at the elements of A, we see that I is one of the elements, so this statement is true. In number 2, it says G is an element of A, but G doesn't appear inside the set A, so this is false. We would rather write that G is not an element of A. In number 3, it says if B is the set A, E, J, U, then B is a subset of A. However, if you look at B, we see that the element J does not appear in the set A. So this is also false. And we would write that B is not a subset of A. In the last question here, D is the set consisting of the elements E and O. And it says if D is the set, then the diagram below shows that D is a subset of A. For D to be a subset of A, when we draw the Venn diagram, we would draw D inside A. So this statement is false. This is not the sketch for D is a subset of A. As I said, D would have to be drawn inside of A. Let's have a look at the different number systems. The first set of numbers that we want to look at are the whole numbers. We use the symbol W for the whole numbers, and it consists of 0, 1, 2, 3, etc. Then the second set of numbers that we want to look at are the natural or counting numbers. We use the symbol N for the natural numbers, and basically the natural numbers consist of all the whole numbers excluding 0. Note that the natural numbers form a subset of the whole numbers because all the natural numbers are contained in the whole numbers. Then the third set of numbers we want to look at are the integers. We use the symbol Z for the integers, and basically it consists of all the whole numbers together with negative whole numbers. So -3, -2, -1, 0, 1, 2, 3, etc. Note that both the natural numbers and the whole numbers form subsets of the integers. Something we'd like to add at this point is that the set of whole numbers W is often also written as N0. In other words, the set of natural numbers, but including 0. Then the set of positive integers we write as Z plus, and this is the same as a set of natural numbers. Then we also have the set of negative integers, which we write as Z minus. Once again, you should pause here and first try these questions before looking at the answers. In the first question here, we have to write a set for each of these number systems. Firstly, the whole numbers. We know that the symbol is W. And of course, it's 0, 1, 2, 3, etc. Then a set of natural numbers, it's N. And we know it's all the whole numbers excluding 0. So 1, 2, 3, etc. Then the set of integers, it's z, and it's negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. Of course, these numbers continue to the left of negative 3 and also to the right of negative 3. So we'll have negative 4, negative 5, etc. and also 4, 3, 4, 5, etc. Then we have to complete the following. N0 is a set of natural numbers including 0. So just a set of whole numbers. Z plus is a set of positive integers. In other words, just a set of natural numbers. Here, something is a subset of the whole numbers, which is a subset of another number system. And we know that the natural numbers form a subset of the whole numbers, and the whole numbers form a subset of the integers. The natural numbers form a subset of the whole numbers, so W, and the whole numbers form a subset of the integers. We have to say whether each of the following are natural numbers and or integers and or whole numbers. 4.1, negative 3 is an integer. It's not a natural number, nor is it a whole number. 0 is an integer as well as a whole number. Then 3215, it's an integer. It's also a whole number. And it's also a natural number. Then negative 7.216 or comma 216. This is a decimal, and we didn't have decimals in any of these three number systems. So this is none. Here we have a fraction, which we also didn't encounter in any of these three number systems.